All right, our second example, another proof. So again, we take a look at the given information. We want to see where it fits in our picture, what we're talking about. Go ahead and mark any congruencies. So the first thing we're told is that NR is congruent to PR. So in our figure, NR is congruent to PR. So we've got one pair of congruent sides. We are also told that RO bisects NRP. So here's RO. We're told that this is a bisector. So what does a bisector mean again? It's bisecting this bigger angle, NRP. Now any type of bisector is going to take that big angle and it's going to divide it into two congruent angles. So we know that NRO will be congruent to PRO, that those are two congruent angles. And then we have to prove that OR bisects NOP. So if we're looking carefully at this, we were told that RO bisects NRP. So this down here is bisecting this angle on the bottom. What we're asking to prove is that OR, so if you were to start at the top and go down, that even though it's the same segment, you want to prove that OR is a bisector for the top angle, NOP. So it seems like very similar information, although what we were given is a bisector for the bottom angle, and we have to prove that it's a bisector for the top angle. All right, so what do we need to show in order for OR to bisect angle NOP? Well, we need to show that OR is an angle bisector. And you can show that something's an angle bisector if you can show that you have two congruent angles. So it's nice to think about these questions, before you start a proof so that you know kind of where you're heading. You want to end up saying that we've got two congruent angles up here. If we can show that these two angles are congruent at angle O, then that means that this must be a bisector. So that's where we're heading. All right, now let's work on the proof. We have NR is congruent to PR as our first statement. How did we know that? It was given to us, so given. We also are told that RO bisects angle NRP. That was another given piece of information. All right, so from there, we can go ahead, we marked it. We marked these congruent angles. So let's go ahead and say that those are congruent. We had a good reason to do that. So angle NRO is congruent to angle PRO. Now, do you remember why we were able to do that? Because we were told that we had this segment or this ray bisecting, so that's just your definition of an angle bisector. That's what an angle bisector means, that you have two congruent segments. That's bisector. Okay. So, what else do we have going on? Well, we've got these two triangles and two triangles with a shared side. So remember that shared side will be congruent to itself, so we can go ahead and mark that congruency. OR is congruent to OR. And what's our reason for being able to say that? Remember, that's your reflexive property. Whoa. Just erase that for a second. Got out of hand. All right, well, if you look at what we have three things that are congruent. We've got this set of sides right there. We've got angles that are congruent, and we've got that side in the middle. So if you think about your triangle congruencies, that's your side, your included angle, and another side. So side, angle, side. So right now we've shown enough information to say that these two triangles are congruent. So that'll be our next statement. Triangle NOR is congruent to triangle POR. And our reason was our side angle side congruency. All right, now that you have congruent triangles, you can say that any corresponding parts are also congruent. So remember up here we said our goal is to show that this is a bisector. Well, we have to show that we have two congruent angles. So that's the next thing that we're able to say. We can say that angle NOR is congruent to angle POR, and those are these two angles up at the top. And how do we know that those are going to be congruent? That's your CPCTC. And now that we have those two angles are congruent, we can state that OR bisects angle NOP. And that is the definition of an angle bisector. All right, there's our proof.